Alright guys, so now we are onto our complex numbers. Let's start with what number does I equal? We've mentioned this in the past, but I is always equal to the square root of -1. That's just one of those facts that you need to remember, have it somewhere written on your paper because it's pretty useful information. That's terrible with the -1, but you get the point. Why I equals the square root of -1. So we have the option 1 here. Oops. Okay. Which is equivalent to 5 minus 4i plus 2 minus 3i. So what we got to do is add these together. Now it's two complex numbers, so add them together. It's basically just combining like terms. I think a lot of people will look at this and they will see the parentheses and think that they're multiplying or need to distribute or something, but that's not the case. You're adding two complex numbers together, so just combine like terms. We're going to have, let's see, 5 plus 2. Well, let's not do that. That looks confusing. That makes it look like we're multiplying it. But we have 5 and 2 are like terms, so 5 plus 2 would be 7. And then we also have our I terms. We have negative 4i plus negative 3i, which is negative 4i minus 3i, which would be a negative 7i. Right? You're just combining like terms. You have 7 minus 7i. So number, or I guess it's not really number, but the next one, you're adding and doing the same exact thing. So combining like terms. You've got 2 plus 7. So 2 plus 7 would be a 9. And then you have the I term. You got a 3i plus a 1i, which would be a 4i. You have 9 plus 4i. So just keep in mind you're just combining like terms. Now, when you're subtracting, it's a little bit different. And there are two ways you can go about it. The one thing I said to do was distribute your negative so that you would know you're subtracting everything always. Okay? So if you distribute the negative, you have negative 4 and then negative 5i. Okay? So let's keep that in mind when we're trying to combine the like terms. Let me kind of write down negative 4 and then negative 5i. Alright, so if you have 6, don't forget this stuff is still here as well. 6 and negative 4. So 6 minus 4 would make 2. And then you have 8 minus 5, which is going to be 3. Okay, so when you have a negative, just go ahead and distribute that negative to both of these numbers, just so you don't forget that both of them are being subtracted. Okay, a lot of people forget to do that. For me, it just helps me make sure I'm not subtracting the wrong numbers from one another. So we can try that again here. Let's distribute this negative first and foremost. Okay, so that'll be a negative 2, and then a negative 6 would be a positive 6i. Alright, the first group we can keep the same. It's the second group we need to change. So if you combine your like terms, you've got 4 and then minus 2. 4 minus 2 is 2. And then you have the I term. You have a negative 2i, and then you have this plus 6i. So negative 2 plus 6 would be positive 4i. Alright, so again, it's just combining like terms. Now at this part, though, notice there's no plus sign or a minus sign between these. So you're not adding or subtracting them. In this case, you're actually multiplying. So this is where you start distributing, you start using your FOIL method or whatever the case is. But notice, like I said, there's no plus or minus. That means you are multiplying. So now you should be multiplying a lot of these numbers together. So distribute the 3. And this is, like I said, let me start from the beginning. This is what I do. So I have these two terms that I need to distribute. I have the 3 and then I have the 4i. So what I like to do is cover up one of these. Okay? So let's cover up that 4i for a minute. Let's distribute the 3. We have the 3. Hold on a second, I'm doing too much here. The 3 times 2, which is 6, and then I have 3 times negative I, which is a negative 3i. Then what I'll do is I'll cover up the 3 and I'll distribute the 4i now. So if I distribute the 4i, then I have 4i times 2, which is 8i. And I'm just going to keep adding this as one long line here. And then 4i times negative I would be a negative 4i squared. Because an I times an I makes an I squared. Now here's a fact that you need to remember. It's that, remember I equals the square root of negative 1? Well, if I square it, then I squared equals just negative 1. So this fact is one that we're going to need to remember. Anytime you see I squared, it's equal to negative 1. So in this problem, I have an I squared. I'm going to change that to a negative 1. So let's spell 6 minus 3i plus 8i. But here it's negative 4 times negative 1. Oops, that looks terrible now, doesn't it? Because I squared is negative 1. So I've changed what was I squared to negative 1. So if I kind of complete this course, I still have all of this. I can combine it at any point I want to. But the end's negative 4 and negative 1 is a positive 4. So now you're adding just a couple like terms. You've got 6 and 4 that you can combine together, which makes 10. And you have negative 3 plus 8, which makes 5. So you have 5i. All right. So this is the same exact problem pretty much. You're going to distribute here. Remember, there's no plus sign, no minus sign in between them, so that means you're multiplying these together. So remember what I said? I kind of cover up one of these and distribute these one at a time. So let me cover up this second term here, and let's distribute the 3. The 3 times, dang it, did it again. 3 times 3, which is going to be 9, and then the 3 times I, which is, or negative I, which is a negative 3i. Then what I can do is I can cover up the other term. Sometimes, man, sometimes. All right, cover up the other term, right? And then distribute the I now. So, let's see. I'm going to multiply I times 3, which is a positive 3i. And then I times negative I makes a negative I squared. Now, don't forget, we just wrote down a second ago, but I squared is equal to negative 1. So you see this I squared right here? It's not, I'm not talking about the negative in front, I'm just talking about the I squared. It's equal to negative 1. So we'll have 9 minus 3i plus 3i minus negative 1. Okay, a lot of you will forget that the negative on the outside here is its own negative. It's separate. It's not part of this negative 1. So we're going to have that negative still, but then when I plug in this negative 1, I kind of have this 2 negative thing going on. But so many people tend to just write minus 1 at the end. But that's not the same thing as minus negative 1. So please be kind of careful about that, because that's probably the biggest and most frequent mistake people make. So what this really is minus a negative would actually make that a plus 1 at the end. And that's where, of course, when you combine the other terms, that makes all the difference. 9 plus 1 becomes 10. And then, of course, negative 3i plus 3i, that becomes 0i. We don't have any i's left. We just have 10. All right. Oh boy, okay, so here's what I would do. On these problems, with these quadratics, the quadratic formula by far is the most reliable method. So it's definitely a long method, and one of those times where I think a graphic calculator would certainly help, but it's a method that we can do nonetheless, okay? Let's use our quadratic formula. So the quadratic formula is negative, hold on, make sure I have enough space here. All right, the quadratic formula is negative b plus minus the square root b squared minus 4ac all divided by 2a. So here I have a is equal to 1, b is equal to negative 9, and c is equal to 20. So if we plug all of those in, we'll have negative 9 plus minus the square root of negative 9 squared minus 4 times 1, let me move this out of the way, times 20. All divided by 2 times 1. So if we just simplify this, the negative 9 will become a positive 9. The plus minus, here we go. Negative 9 squared, negative 9 times negative 9 is 81. And then 4 times 1 times 20 is 80, so that'll be minus 80. All divided by 2 times 1, which is 2. So let's keep simplifying. We have 81 minus 80. That's just going to be a regular 1, right, over 2. So again, all I've really focused on from this step to that, from here to here, is just, 81 minus 80 is just 1. But now what is the square root of 1? Well, square root of 1 is also just 1. So it's going to be the same as 9 plus 1 over 2. Now I've got two things going on. I'm almost done, but I have two equations written at the same time here. I've got 9 plus 1 over 2, and I also have 9 minus 1 over 2. So these two problems are the same as this. It's just they got the plus and the minus written separately rather than together. A 9 plus 1 over 2 would be 10 over 2, which is 5. And 9 minus 1 over 2 would be 8 over 2, which is 4. So we got two answers, 5 and 4. So that would be option 1. All right, here again, the quadratic formula that you can use. So quadratic formula is big on this. One of those reasons, again, why having grab a calculator would make this faster, but nonetheless, you're still capable of this. It's just going to take you a little bit longer. So here, A is equal to 2, B is equal to negative 3, and C is equal to negative 2. So let's plug these in. We're going to have, well, grab a calculator can't do all of this, I don't think. But let's continue. So remember the formula is going to be negative B, so it'll be a negative 3 plus minus the square root of B squared, which is negative 3 squared, minus 4 times A, which is 2, and C, which is negative 2. All divided by 2 times A, which is 2. So this negative 3 is going to be a positive 3. Negative 3 squared is 9. And then 4 to negative 2 will be minus negative 16, which would be plus 16. Because it'll be a minus a negative number, which is why I have the plus sign there. And then over 4. So 9 plus 16 is going to be 25. So this will be 3 plus minus the square root of 25 over 4. And of course, square root of 25 is 5. So you've got 3 plus or minus 5 over 4. So this is where you have your two equations again. You've got 3 plus 5 over 4 and 3 minus 5 over 4. So those two are the same as this one. It's just the plus and minus are written separately rather than at the same time. 3 plus 5 is 8. 8 over 4 is going to be 2. 3 minus 5 is negative 2. And negative 2 over 4 is negative 1/2. Or negative 0.5. So negative 1/2 and 2 are the answer. Alright, quadratic formula once again. Let's try to make this kind of fast. A is equal to 1, B is equal to 5, and C is equal to 7. So we have negative 5 plus minus the square root of 5 squared minus 4 times 1 times 7, all divided by 2 times 1. So this will be negative 5 plus minus the square root of 25. It's 4 times 1 times 7, 28, so it would be minus 28 over 2 times 1, which is 2. Now 25 minus 28 is negative 3. Alright, now here's the thing. If you try to use your calculator on this, your calculator would say square root of negative 3 is an error. Right? So we have to remember this square root of negative 3, let's take it over to the side. You have to separate the negative from the 3. And don't forget, we've already mentioned this, the very, very first thing in this video was that I equals the square root of negative 1. So here, when you separate the negative from the 3, you have I now. Okay? Square root of negative 1 becomes I, and then you still have your square root of 3. So the square root of negative 3 simply becomes I square root of 3. So let's go ahead and put that back in our equation. So we have negative 5 plus minus I square root of 3, right? Because that's what we changed. We converted this into that. And then, of course, we still have over 2. And there's no more that we can simplify. That's it. So there's our final answer. All right, this one, it's much faster. Since there's only x squared, there's no other x's. If we just try to solve it regular equation style. So draw the little line down the middle. Let's try to get this x by itself. Okay? There's no. You could use the quadratic formula if you wanted. If you use the quadratic formula, remember a is equal to 3, b is equal to 0 in this case, and c is equal to 48. You'll get the same thing. It'll just take you 10 times longer. All right. So let's try to get the x by itself. We'll start by subtracting 48 on both sides. This leaves me with 3x squared equal to negative 48. And then we can divide by 3 to have x squared equal to negative 16. And then we'll take the square root on both sides to get rid of the square. So it would be x equal to, now again, the square root of negative 16. Let me do this in red. Because we can't do the square root of negative 16, it would be an error. But just like the negative 3 in the last problem, separate this negative from the 16. And remember, I equals the square root of negative 1. So that square root of negative 1, we're just going to call it I. And the square root of 16 is 4. But remember, because we're having an equation here, this is technically a positive and negative version of 4i. So you have the plus minus, but of course you have your 4i. And thankfully it's multiple choice, so even if you forgot the plus and minus, you at least have your answer right up there. It tells you positive 4i and negative 4i. It's the only answer choice that has the 4i in it. So, I mean, that by default, you should be able to resort to that even if you forgot the plus and minus. The fact that it's both positive and negative 4i. Here, the same idea. Let's kind of just solve this old-fashioned equation style. So, x plus 1 squared minus 4 equals 0. And old-fashioned, let's get rid of this 4. Let's add it to both sides. That leaves me with x plus 1 squared equal to 4. Now, notice the plus 1's inside the parentheses. I can't really move that plus 1. You know, a lot of people would try to subtract 1 here, but you can't. Okay? Because it's inside the parentheses. You have to get rid of the parentheses, which means you have to get rid of the square. The opposite of squaring something is square rooting it. So let's go ahead and square root both sides. And that will remove the exponent. So now I have just x plus 1 equal to, well, here's where it gets a little bit tricky, but square root of 4 is a positive and a negative 4. We just mentioned that in the last question. So here's two equations, okay? You have x plus 1 equals a positive 4. You also have x plus 1 equals a negative 4. Again, these two are the same as that down there, except both written out separately rather than at the same time. But if you solve for both of these x's, you subtract 1, you'd have x equal to 3. And this one would be x equal to negative 5. Alright, so you do get two equations, and you get two equations because technically the square root is a positive and negative. So then you have the positive and negative 4, and you subtract 1 from both of those. Then you get your 3 and your negative 5. So the correct answer there is option 1. Alright, very similar. Well, no, this one's another quadratic formula. I looked at it for a second and was wrong in terms of what I thought it was. Here, there's an issue with this problem. It's not written properly. We want it to be written like this, where we have ax squared plus bx plus c equals 0. We want absolutely nothing on one side of the equation and then everything on the other side. So here you can see that the 12 is clearly on the wrong side. So let's move this 12 by subtracting it on both sides to have this equation proper. It'd be x squared minus 11x minus 12, and then it would equal nothing. So that's the equation we want to work with. This is what we use on the quadratic formula. A is equal to 1, b is equal to negative 11, and c is equal to negative 12. So, quadratic formula, we'd have negative b, which would be negative 11, plus minus the square root of negative 11 squared, minus 4 times 1, times negative 12, all over 2 times 1. This would become positive 11 plus or minus the square root of 121. And then 2 negatives will make a positive, so this would be plus 4 times 12, which is 48, I think. So, and then over 2. So 121 plus 48 is 169. Alright, and then of course it's over 2. Now the square root of 169 actually is a perfect square. The square root of 169 is 13. So this is 11 plus minus 13 over 2. So again, you have two equations. You've got 11 plus 13 over 2. You've got 11 minus 13 over 2. 11 plus 13 is 24, and 24 divided by 2 is 12. And then 11 minus 13 is negative 2 over 2, which is going to be negative 1. So our answers are 12 and negative 1. So option 2, yeah. All right, again, another quadratic formula. We've got a bunch of these. It's already set up properly, so let's just go ahead and get to work. Negative 6, because that's negative b, plus or minus the square root of negative 6 squared, minus 4 times a is 2, and then c is negative 3. All divided by 2 times a, which is 2. So this will become a positive 6 plus minus square root. Negative 6 squared is 36. And then I got 2 negatives again, so this will become plus 8 times 3, which would be 24. All divided by 2 times 2, which is 4. So we have 6 plus minus. Now, 36 plus 24 is 60. Right? Yes, definitely 60. Alright, now here's the issue. 60 is not a perfect square. It would be a decimal. And we don't really want to have a decimal. So what we're going to do is solve this one, or simplify the square root of 60. So 60 is not a perfect square, but remember, try to find the perfect square that is divisible into 60. 4 is perfect square, 9 is perfect square, 16 is perfect square, 25, 36, all of these are perfect squares. Turns out 4 is divisible into 60. We can use that. 4 times 15 makes 60. So the square root of 4 becomes 2, and the square root of 15, well, is still the square root of 15. All right, but now we're replacing the square root of 60 with 2 square root of 15. So we're going to have 6 plus minus 2 square root of 15 over 4. Now there are 3 numbers to look at here. It's the 6, the 2, and the 4. Basically, everything that's outside of your radical. We don't really want to look at the 15 because the 15 is stuck inside the radical. We can't really do anything about it. We can't change it because it's trapped inside that radical. But the 6, 2, and the 4, we can actually reduce. All 3 of those numbers are divisible by 2. So if we can divide all of them by 2, which we can, we don't have to worry about the 15 since it's inside the radical. We can reduce all 3 of those numbers down. The 6 divided by 2 becomes 3. The 2 divided by 2 becomes 1. Right? So we can leave the 1 there or not. We still have the square root of 15, of course. And the 4 divided by 2 is 2. So the answer that we're looking for here is 3 plus minus the square root of 15 over 2. And that's option 3. Option 3. The difference between option 3 and option 4 is here you have a negative 3, but we never have a negative 3, right? We have a positive 3 all the way around, but we have a plus square root of 15 and a negative, or a minus square root of 15. So that's why it's option 3 instead. All right, the conjugate. Remember, the conjugate is if you have a complex number, a plus bi. The conjugate is a minus bi. So all you're doing is changing the sign in front of I. So here I've got negative 6 plus 4i. Its conjugate would be negative 6 minus 4i, where you simply just change that sign in front of the I term. All right, and we're almost done. Thank goodness. So here, we're going to use that conjugate rule a little bit. We have 4 plus 3i over 3 minus 2i. Now, how we're going to solve or simplify this, figure out which the answer is is we're going to multiply this by the conjugate of the denominator. Now, the denominator is 3 minus 2i, which means the conjugate of 3 minus 2i is 3 plus 2i. So we're going to multiply the top and bottom by that conjugate. All right, let's put these in parentheses too. All right, now we're multiplying. So when we multiply, we distribute. So let's distribute. Let's focus our attention on the top first. Let me cover up the bottom so that's not in our way. All right, and let's also kind of cover up one of these up here because we're distributing, right? Let's not get distracted. We're going to distribute the 4 first. So 4 times 3, which is going to be 12. And then 4 times 2i, which is 8i. And then let's distribute the other terms. Let's move this over here, and let's distribute 3i. So 3i times 3 is 9i, and 3i times 2i is 6i squared. Now don't forget, we already mentioned this in the previous one, but I squared is equal to negative 1. That's a rule that we're going to use here. That's what I'm going to do in my next step. Is I'm going to replace that I squared that I have with a negative 1. So that's going to make that a negative 6. So now I can combine my like terms. 12 minus 6 is 6. And 8i plus 9i is 17i. So the numerator is going to be 6 plus 17i. Now let's just use the denominator. Erase this so I have a little bit more room. All right. Let's go back to, oops, oh, I didn't even do that. Anyway, let's put that what we had. We had 6 plus 17, that was our numerator. All right, so we had just distributed on top, right? The 3. All right, time to just, this is why you don't get distracted by you do things. All right, 4 plus 3i and 3 minus 2i. And we were multiplying the top and bottom by 3 plus 2i. All right, we had already done that to the top. We just distributed the top. But now we have to distribute to the bottom. So let's cover up one of these, and then let's start distributing to the bottom. So we have 3 times 3, which is 9. 3 times 2i, which is 6i. And then let's distribute the other side. Now it's a negative 2i. Let's keep that in mind. Negative 2 times 3 is negative 6i. And negative 2i times positive 2i is negative 4i squared. Remember again, I squared is equal to negative 1. So that's what I'm going to do in my next step. I've got all of this, but I have negative 4 times negative 1, which will become positive 4. So I have 9 plus 6i minus 6i, and this becomes plus 4. So when I add these together, 9 plus 4 will give me 13. But if you look at 6i minus 6i, that becomes 0i, and those cancel out. So the bottom is just 13. So there's my answer. I've got 6 plus 17i over 13, which is answer choice option 1. All right, that's going to cover it, guys. That's it for the review. Hopefully you got over this pretty well enough. Good luck on your quiz. We'll see you later.